So in this video, we are going to learn what is dynamic memory allocation. So in C++, dynamic memory allocation is done by using the new and delete operators. So these two operators has been used to do dynamic operation in C++, new and delete. We have seen this as a keyword, and these keywords are used for allocating dynamic memory. So there is similar features in C with the help of malloc, calloc, and free functions. We can perform dynamic memory allocation. So in C, these are the functions. With the help of these functions, you can do the dynamic memory allocation as well as deallocation. So these are the functions. This means they are supported by external library, whereas C++ grab this idea of dynamic memory allocation into the core of language features by using the new and delete operators. So in C, this dynamic memory allocation is done with the help of these functions, whereas in C++ it is done with the help of this operator. These are called as operator, new and delete. So unlike C's dynamic memory allocation and deallocation functions, new and delete in C++ are operators that are part of the list of keywords used in C++. So although in both C and C++, dynamic memory is allocated in the heap area and gets a pointer returned to the object created. So when you create a memory management using the dynamic memory, the heap area, a special memory area are called as heap area. On that area, memory gets allocated to the member variables. It could be your array, it could be your object, and so on. So C++ is a stricter in the construction norms. C++ never gives the memory of allocated element directly access to initialize, but constructor is used instead so as to ensure that initialization is guaranteed. There is no accidental access to an uninitialized object. The wrong sized object can't be returned. So these are the tasks are carried out or ensured by the constructor. Initialization is guaranteed by the constructor. As well, there is no accidental access to an uninitialized object, and there will not be any wrong sized object can be returned. So this is ensured by the constructor. Prior to the use of object created, proper initialization is vital. This is one thing can help in avoiding many programming problems. So keep in mind, whenever you create object, you need to do a proper initialization, and this plays very important role while writing your program. So the cleanup procedure with the delete operators also automatically cause the destructor. When you perform deallocation of the memory with the help of delete operator, automatically destructor will be called, and whatever code present in the destructor will be executed. We are going to see this, how to create the object with the new, how to delete with the help of example also. So the allocation or deallocation of an object, be it array of any built-in type or any user-defined type, can be controlled in memory at runtime by using new and delete. Why it is called as dynamic memory management is the memory is allocated when your program is in execution. That's why it is called as dynamic memory management. And you can do this with the help of new and delete operators. New and delete operators. So new operator. The new operator allocates the exact amount of memory required by the object during execution. So this new operator allocates the exact amount of memory required by the object during the execution. The allocation is performed on the free memory area called the heap and assigned to each and every program, especially for the purpose of dynamic memory allocation. So whatever memory is allocated by the new operator, it is present the special memory area called as heap. The allocation, if successfully by using the new operator, returns a pointer to the object. If it fails, object, and if it is fails, a bad allocation exception is raised. The memory is allocated by using the new operator, then it will return the pointer to the object, and if it fails, it will simply gives you exception. That is bad allocation. However, on success, we can access the object via the pointer returned by the new operator. We can access the object by using the pointer which is written by the new operator. So for example, when we write student star object, okay, this is the pointer to the object, is equal to new student, is equal to new student. So new is an operator which helps us to create the object dynamically. This is called as dynamic memory allocation. This is called as dynamic creation of the object. That is memory management. And you can do this with the help of pointer to object, and you have to use new operator. So this simple statement will create this student object dynamically. It is memory is allocated when your program is in execution. What happens here is the new operator allocates the exact amount of memory required by the object in the free store or heap area, and it invokes the default constructor to initialize the property of the object. What this new operator will do? First of all, it will check free space on free store or heap area. Along with this, it will execute the constructor which is used to initialize the property of the object. And after this, it will return a pointer to type specified object allocated in memory. It will return a pointer to the object allocated in the memory. However, during the allocation process, if the operator finds that there is not enough space in memory to allocate for the object, so in this case, it simply throws an exception to indicate error. And the exception gives an opportunity to handle the error programmatically. That exception, we will see it later on once we come across that unit. So next is delete operator. As soon as we don't need the allocated space due to object going out of scope and so forth, we can ensure that the memory occupied is returned back to the stored or freed by using delete operator. So the freed memory then again can be reused by succeeding new operator calls. For example, we write as follows: delete object. This is the delete operator, and we have said to delete this object, means whatever memory is occupied by this object will be deallocated by using this delete object. Before deallocation, this delete operator simply invokes the destructor present in the class. So whatever cleanup code you will have, that code you have to put inside this destructor, and that will be invoked before deallocating the memory of the object. The delete expression requires an address of the object and always calls the destructor before releasing the memory. Therefore, all the cleanup operations such as closing a file, open file, releasing a database connection, and so on must be put into the destructor. So whatever cleanup operations, that is a particular operation you want to do before a particular deallocation of the memories happen, that code you have to write inside the destructor. So I am going to demonstrate this, a simple code which is already, we have that program, and simply I am going to add the dynamic memory allocation. Okay, so this is the simple program. We will have the student, and the variables are ID and tuition fee. First of all, I'm going to show you what is the output of this program so that you will understand code in a better manner. So compile it. There are 0 errors and 0 warnings. Execute. So this is the output of this code. It simply shows constructor as a message. It will show student ID is equal to 10, student tuition fee is equal to 50,000, and it will show destructor. So this is the output of this code. Now I am going to explain this code, and what we have written in this code. We have created dynamic memory management by creating the dynamic object. So we are familiar with these two statements. We have used the namespace std, and we have imported or included the iostream header file, and we have class student. So inside the student, we have declared the constructor destructor, and we have declared the display as a function. These are the three members present in the student, and there are two variables, ID and tuition fee. So this is the student constructor, which will show the message constructor. This is our destructor. You are familiar with this, which will show the destructor as output message. And then we have a display function which will display student ID and student tuition fee, that is T fee. So these are the members of the class student. Now in the main, this is the way to create the object dynamically. You have to say student and then star, and then you have to give the name to the object, that is pointer to the object, is equal to new student. when you say new, memory is allocated for this object dynamically when your program is in execution. And now once you create the object, you can access the members by like this. Keep in mind, this is not our normal object. You can't access members of the class by using the dot operator. Instead, you have to use name of the object obj and this arrow. And then you have to mention data member or function. So I have said here obj arrow id is equal to 10 and obj arrow tuition fee is equal to 50,000. I have initialized these variables, and next I have called the function display. This is the way to call the function display. Obj arrow display. Only difference is instead of using the dot operator, you have to use the arrow operator when you create the dynamic object. And this statement will invoke this, call this display function. Whatever code is present will get executed and you will get the output. At the end, I have said delete object. When I say delete object, the memory is deallocated. Before that, this destructor will be invoked, as I said earlier. And then whatever memory is allocated to the object is deallocated by this delete operator. And this is called as dynamic memory allocation. Dynamically, we have created the object. And memory is allocated to this object when your program is in execution. Okay, so whatever I am teaching, is it understandable?
Yes, sir.
Yes, sir.
Okay, any doubts in this, whatever I am teaching, dynamic memory allocation?
No, sir.
Okay, so simply instead of creating object here, you have to make the pointer to object. I think at least you are familiar with the pointer. So this is the pointer to the object, and this arrow is used to call them to access the members present in the class. That is the difference. And behind the scene, the memory is allocated to this object whenever program is in execution, which is not visible to your eyes, but it will happen. This is not visible to your eyes, but behind the scene, the memory is allocated to this object when your program is in execution, and accordingly operations are performed. These variables are initialized, this display function is executed, and then when you say delete, that particular object is deleted. Before delete operation, only thing is that this destructor will be executed. So this is the simple code that we have already studied, student, and I have just added this pointer to object so that you will understand dynamic memory allocation in easy way. So understood?